All right. Hi, everyone. I'm Connor from MWR. So I'm going to talk to you guys today about a IPC privilege escalation vulnerability that we found in MacVim. So let's start with a bit of history. We were doing a security assessment on some Mac-specific software, and I identified some functionality that would require elevated privileges to be able to use it, right? But when I clicked on the button to use the functionality, it didn't get prompted for a login or anything like that. It just worked out of the box. That immediately raised an alert. Must be something like an IPC mechanism. I then researched this IPC mechanism and determined that it was, in fact, aggressively deprecated and did some research to find other software. So just a bit of background for what IPC actually is. This is typically used whenever you want two processes to communicate with each other. You can think of our operating systems as just really bags of processes communicating with each other all the time, right? So without IPC, our machines would be fairly useless. A really kind of like party trick example would be using something like TCP dump and piping the output of that into APlay, which will just make a bunch of beeps and bops depending on what's happening on your network. So there are different ways to do this. You have files, sockets, and signals. But on macOS, this particular mechanism is called distributed objects. All right, so how does this work? We have a server application that wants to essentially vend a class to other applications on the same machine. The vended class executes in the context of the server application, so with its permissions, right? And then these classes are bound to a service as opposed to an IP and a port pair as you might be used to. Okay, so we're going to jump into some code. I have to apologize in advance. It will be Objective-C, but hopefully we can still enjoy it. So this is an example server that has an implementation called service object, and it defines a method called getInfoCommand that takes an integer and returns a pointer to an NS string. So this would be the vended object that any other process on the machine can just essentially call. If we look at the main function, what this looks like is we create an NS connection, we initialize the service with a name, and we pass the root object, which again is the vended object. If we look at a client, it's very easy to use this. You import the definition for your service object. You then create an NS connection with the registered name. And if you can successfully connect to the service on the other side, you get back a pointer. If not, it's null. And then finally, you can see we can finally call object.getInfoCommand and pass it an integer. So essentially, we need two things to be able to reproduce a malicious client for the service. We need the definition of the service object, as well as the service name. So we have two approaches that we can use to kind of tackle this problem. You can take a static route, so using a decompiler like Hopper or Radare2. If anyone doesn't know, you just pass it a binary. It gives you some very verbose information about the binary, as well as all the instructions that it's executing. Then we can take a dynamic approach where we use something like Freda to just hook the server object directly, have a legitimate client connect to it, and just dump the arguments to see what this particular vended class is capable of. So this is what I like to call the lazy approach. You can use something like strings with grep or even just Radare2, take every single binary on your system and just pipe it through it and see if there's any indications that these interfaces are being used. Then there's the Hopper easy mode, which unfortunately I only found out about after the assessment that I needed this for. But as you can see, there's a very nice context menu there, export Objective-C header file, which gives you the interface declaration directly. Unfortunately, that doesn't give us the type. So you'll see getInfoCommand long v1. So we don't know what type this function is expecting. This is the perfect opportunity to talk about Freda again. So we can use Freda Trace to essentially attach to the server and then just dump any class that is or contains service object and any method for that class. You then modify the handlers just a little bit, and it'll print the parameters as they're being passed through when you're connecting, again, a legitimate client. So here we can see getInfoCommand takes an integer 0x141. So now we know that the type there is supposed to be an integer. I'd like to give a shout out here to Objection. The SensePost team really built some phenomenal tooling. This was incredibly useful. You can make a very small change to it to get it to work using macOS as a host, because the iOS Objective-C runtime is very similar to the macOS Objective-C runtime. At the end of the day, what you can do is just make the small change, attach Objection to it, and run a command like iOS hooking watch service object. And then you get all the information you need to be able to reproduce something like this. So we've got 50% of the information we need. We still need the service object's name, or the service name. And we can get that also using Freda very easily. You can see there in the middle of the screen, right around the 111 millisecond mark, we have NS connection, register name, applications, MacVim, app connection. So that would be the server name, or what is equivalent to your IP and port pair. Okay, now we have everything we need. The final step is to just copy-paste. So before we get to the actual POC, let's just take some time to talk about what's in the wild. So we identified 3 targets. The first one was MacVim that suffered from a privilege escalation. The second one was a completely different set of software that also suffered from a privilege escalation. And then the final one was a piece of software that would essentially allow other software from the same vendor to configure it. However, because they were using this specific interface, any software on the machine could then connect to that settings them and just change whatever they wanted to. Let's do some source code snorkeling. So can anyone in the crowd maybe spot the method that looks particularly dangerous here? Second of last. The executed login shell one. So it's this one right there. So ignoring the fact that this is open source software, if it was closed source, you wouldn't even need to do any reverse engineering. This is incredibly verbose. It takes a path and it takes arguments. So there we have code execution, very, very easily. So before I start the demo, let me just clarify a few things. You do need to have code execution on the target machine already to be able to exploit this. And what we're going to do is we're going to go from that code execution, and I'm going to get a root shell or a interpreter reverse shell. So we're starting off, if I can figure out how to play this. There we go. Okay, so just we have no active sessions. We have what I like to call the stager in the background, because the stager executes the stager. And you'll see it tries to poll every 5 seconds to determine whether or not it can see the MacVim process. So I'm going to start that. See no connection, and no sessions yet, because obviously nothing has happened. There's the first no connection. Then I'm going to execute MacVim. Now, at this point, we wouldn't expect to see a connection back because it's not root, so I don't particularly care about the shell. You will see a yay message at the bottom there that just indicates we were able to connect successfully to the IPC component. Cool, we close that. I'm going to run MacVim with an alias that's just equivalent to sudo MacVim. And we should see another yay followed by a few seconds later, interpreter calling back. There's the first yay. And we have a callback. And then just to demonstrate that we are in fact root, we just do a quick who am I. All right, before I open the floor to some questions, I think it's just time for some, thank you guys. So, I forgot to mention this at the start, but my first thought when I saw this was there's no way that there's anything out there in the wild that's still using this. It's been, I think, about 8 years, but this just goes to show you there is still quite a lot of software that will use these deprecated interfaces. In fact, it's so bad, if you start a new Xcode project and you try to use this, it'll fail immediately when you try to connect to the service. So you have to target a very old runtime to even get the client to work. More space for research. So I haven't looked at iOS at all. There might be some old component that for whatever reason ends up using this, as well as proprietary software. I'm mostly focused on open source things. Then finally, I just want to thank everyone who supported me during research. I think, Chris, you're here as well, the rest of the MWR team, Charisse. Yeah, thank you so much, guys. Right, any questions?
Hi, that was a great talk, for one. I just have a question about the difference between RPC and IPC.
Okay, so IPC isn't necessarily going to equate to a remote procedure call. If you look at signals, for example, it's a very easy way to just signal something went wrong. Maybe you get like an error code or something back, but you're not invoking another function. So you can think of RPC as just IPC with an extra step of, I tell you do this, go do that. Cool, pleasure. All right. The man, the myth, the legend.
Hey, yeah, great talk. Just wanted to confirm, so to actually like get the reverse shell back, you need the user to run vim in sudo.
Yes, absolutely. So the stager will check every 5 seconds, is macvim running? Then the stager checks, are we running as root? And only then does it actually trigger the meterpreter reverse shell. But you can obviously change that if you just wanted a boring old normal shell.
Oh yeah, yeah, but as you said, this is Prevesk, and
yeah, absolutely.
I personally run vim with sudo all the time. So,
just to clarify, it's macvim specific, right? So it doesn't work for just any old vim. It has to be the Mac. Do you happen to use that, David? Okay. Awesome. All right. Thank you so much, guys. Appreciate the opportunity. Really enjoyed it.